Hi class. In this video, we are going to continue chapter 6.3 Le Chatelier Principle, part 2. So previously in the Google Meet lesson, we have already talked about what is Le Chatelier Principle, what is the factors for the concentration, factors of the pressure and volume, and also additions of inert gas at constant volume and constant pressure. So what these factors will affect the equilibrium position. So in this video, we are going to talk about the effects of temperature and the effects of catalyst. So when a system is subject to change, when there is disturbance, your system will respond or it will adjust, okay, to reduce this effect, to reduce the effects of disturbance. So we want to see if I change the temperature, what happens to the system equilibrium. All right, so first of all, remember that previously Madam has talked about the values of K, your equilibrium constant. So if your temperature remain constant, the value of K will remain unchanged. But when there is changes in temperature, there will be a change in the value for your equilibrium constant K. So to apply your Le Chatelier principle, there's a guideline for you to interpret the equilibrium shift. So first of all, in the first step, you need to identify a reaction is given. What is the type of reaction? So the first type of reactions, endothermic reactions, where you have this delta H, a positive value. Okay, so for endothermic reactions, you have already encountered this one before. We just do a little bit of recap. Yeah, endothermic, delta H equals to positive. It refers that the system will absorb the heat. And another type of reaction is exothermic. So for an exothermic reaction, delta H, we have a negative value, and the heat is being released. Okay, so type of reaction, endothermic, heat is absorbed. Okay, you have a positive delta H value. For exothermic, heat is released, and we have the negative delta H value. And the second step is the temperature of the system increase or decrease. So this is your disturbance. Okay, so this is the disturbance. So that means it's an external adjustment. If I increase the temperature of the overall system, then what happens to the reaction? If I decrease the temperature, then what happens? Okay, so there is two scenarios. First of all, if the temperature increases, the system or the reaction will favor endothermic reaction. Okay, why do we say temperature increases, it favors endothermic reactions? Remember that Le Chatelier, when there is disturbance, we want to reduce the effect, isn't it? So if you increase the temperature, the system will want to lower down the temperature. Okay, therefore the extra heat will be absorbed. Therefore, endothermic reactions is favored. And if the overall temperature decreases, okay, the system or the reactions will favor exothermic reactions. Why is it so? If you think about this, temperature decreases. Okay, according to Le Chatelier principle, we want to raise up the temperature. So at this time, the reaction will want to release more heat so that we can increase back the temperature. Okay, so please remember and then try to understand two of this sentence in your step 2. Next, we have step 3. Determine the equilibrium shift. Is it to the left, to the right, or no change? Step 4. What happens to the concentrations of reactants or product? So this is after the equilibrium shift. Okay, the result of the shift, the effect of the shift. And last one, and the additional points over here is only for the factors of temperature. Okay, whereby change in temperature will relate to the change of K. So after determining the shift, you need to identify whether you are producing more product or you are producing more reactant. Okay, so value of K will decreases or increases or no change. So you have to identify this. All right, so given in the example questions 1, You have N2O4 gas as the reactant and NO2 gas as the product. So in our first step, we need to determine the type of reaction. So focus on the value of delta H. You have a positive value. This positive value indicates that the forward reaction is endothermic, in which your heat will be absorbed. So of course, when the forward direction is endothermic reactions, the reverse equation or the reverse reaction will be exothermic. So looking at your first disturbance, if the temperature of the system is increased. So just now we say that when the temperature increases, the system favors endothermic reaction. Alright, so this sentence is fixed. This one is our step 2. If temperature increases, the system favors endothermic reaction. So you have to refer to the equations given. So the endothermic reactions refer that the reaction will proceed to the right-hand side. So we can say that the equilibrium shift to the right until Q equals to K. Okay, so first of all, determine the type of reactions. And then, depends on the disturbance. If the temperature increase, it favors endothermic reaction. Therefore, the equilibrium will shift to the right. Okay, so following your guideline, here is your first step, and then here is your second step, and then equilibrium shift will be your third steps. And then number 4, you need to identify the concentration of your reactants and product. So if your equilibrium shifts to the right, concentrations of N2O4, the reactants, will decrease, whereby the concentrations of your product NO2 will increase. And last step, we have our step number 5, which is to determine the values of K. So if you look at this Kc, we have the Kc expressions products on the top and reactants at the bottom. So if the equilibrium shifts to the right, concentrations of product increases and the concentrations of reactant decreases. So the value of my K constant, okay, equilibrium constant, will increase at the same time. So this one you need to refer to your Kc expression. So the value of K will decrease. Okay, so for the factors of temperature, point number 5 is a must. You must always remember factors temperature must state the changes to our K constant. Next, using the same equation, if the disturbance is now lower down the temperature. So if the temperature decreases, the system favors exothermic reaction. So based on the balance equation, the exothermic reactions proceed to the left-hand side. So we will follow this arrow for exothermic reactions. That means the equilibrium will shift to the left, okay, in order to re-achieve the equilibrium until Q equals to K. So if the reactions proceeds in the reverse directions towards the left, so your after the equilibrium shift, the concentrations of N2O4 will increase. The concentrations of the product will decrease. And therefore, if you refer to this Kc expression, after the equilibrium shift to the left, the concentrations of NO2 will decrease. And then for N2O4, the reactant will increase. That means for the Kc value, it will decrease. You don't have to change the positions of reactant and product. You just remember that we follow which reactions is favor. That depends on your equation. We identify is it towards the left or towards the right. So finally, we need to make a conclusion for this Kc value. So Kc value decrease. Alright, madam give you one more example, and this example you can copy down. It's not in the notes, it's an addition examples that madam gave you. So given a balance equation with the delta H value, so the questions asked, based on the above reactions, predict the equilibrium shift if the temperature of the system is increased. So remember your first step, you need to determine the type of reaction based on the equations given. So giving in the equation, you have a negative H value. So the negative H value indicate that the forward reaction is exothermic. Okay, forward reaction is exothermic. And at the same time, the reverse reaction is endothermic. So every time when you see this kind of questions, you need to determine the type. So once you determine, write it out. Okay, so we can write out the sentence. The forward reaction is exothermic. So when the temperature increases, the system will favor endothermic reaction. So that is your step 2. So you must remember step 2, the sentence is fixed. Temperature increase, system will favor endothermic. If temperature decreases, the system will favor exothermic reaction. Okay, so since you know the temperature increase, it will favor endothermic reactions, then we go back to the equation just now, whereby we have already indicate which one is endothermic reaction. Okay, so looking at this one, endothermic, the reaction will proceed to the left, a reverse reaction. So we can say that the equilibrium will shift to the left or shift in a reverse reaction. You can either write to the left or reverse direction. Okay, reverse direction until Q equals to K. After you have determined the equilibrium shift, then you need to identify their concentration. So concentrations of SO2 and O2. So after equilibrium shift to the left, the concentrations will increase, while the concentrations of SO3, okay, concentrations of SO3 after equilibrium shift to the left, the concentrations will decrease. And our last step, using your Kc expressions. Okay, Kc expression. So the concentrations of SO2 and O2 increasing, concentration of SO3 is decreasing. Therefore, the values of our Kc decreases. Okay, very important. So even though the questions didn't ask for the value of Kc, but remember that these 5 steps are all your explanation. So Kc decreases. So we have our first step, determine the type of reaction. And the second step, we have to identify which reactions is favor. And then number 3, to determine your equilibrium shift. And then after the equilibrium shift, identify the change in concentration. And then lastly, and the most important one, is the value of Kc. And the last factors we have here is the effect of catalyst. So the definitions of catalyst, a catalyst increases the rate of reaction by providing an alternative pathway that has a lower activations energy. So by using catalyst, it will shorten the time taken for a reaction to reach equilibrium. So remember about the functions of catalyst, we want to increase the rate and we want to shorten the time taken. However, you need to remember that the additions of catalyst will not affect on equilibrium position. That means if I add catalyst into a reaction, the equilibrium positions will remain unchanged. Okay, same things goes for Kc and Kp. Because you didn't change anything about temperature, so Kc, Kp value will remain unchanged. And lastly, adding catalyst will not affect the equilibrium concentrations as well, because no equilibrium shift, the concentration will remains the same. Alright, so have a little bit of review on the factors. We have talked about the concentration. Okay, concentrations of reactant or product depends on what the questions mentioned about the disturbance. We have talked about the pressure or volume. They are considered as one factors. We have talked about the additions of inert gas and depends on the condition, whether you're adding inert gas at constant volume or adding inert gas at constant pressure. And then we have also talked about the factors of temperature. So remember, temperature will link to the value of K. Okay, and last one is catalyst, but catalyst will not have any effect on the equilibrium position. So for the example question 1, you need to try to practice how to apply Le Chatelier principle and then how to explain the equilibrium shift if there's any. So for these questions, again, you are giving a balanced equation with a delta H value. So determine in which direction will the reaction shift to re-establish equilibrium, the effect on the equilibrium concentration, and then the change in the value of K, if any, if the system is disturbed by, first of all, adding O2, removing NH3, or increasing the temperature. Alright, so looking at the first scenario, adding O2. So when we adding the oxygens, it will increase the concentrations of O2. So remember, the square bracket represent the concentration. So when the concentrations of oxygens increasing, the equilibrium will shift to the right to re-establish the equilibrium position. Okay, so remember the Chatelier principles. You want to reduce the effects of your disturbance. So as a result, the concentrations of NH3 and O2 after the equilibrium shifting to the right, the concentration decrease, and the concentrations of N2 and H2O increase. Since the H2O given over here, you have the gaseous phase, so we can talk about the concentrations. If the phase given for H2O is liquid, then you don't have to mention about the concentration. Okay, so please pay attention to the phases. Lastly, the value of K. Okay, in this case, the temperatures doesn't have any changes, so the values of K remains unchanged. Alright, for the second scenario, removing NH3. So if you're removing your NH3, the concentrations of NH3 decreases. Therefore, the equilibrium will shift to the left, okay, to replace the concentrations of NH3. Okay, so equilibrium will shift to the left to regain equilibrium positions. So as a result of this equilibrium shift, concentrations of NH3 and also O2 increase. And at the same time, concentrations of N2 and H2O decreases. Lastly, the value of K remains unchanged as the temperature remains constant. So our last scenario, increasing the temperature. So it's the same meaning as increasing the temperature of the overall reaction. So first of all, identify the type of reactions. So depending on your value of delta H, negative value indicate that your forward reactions is exothermic. So forward reactions exothermic. And the reverse reactions automatic will be endothermic. Okay, so we write in sentences, the forward reactions is exothermic. So when the temperature increases, endothermic reactions is favored. So instead of saying the system favors endothermic reaction, you can also make your sentences. As long as you can link that temperature increases, it will go for endothermic reaction. Alright, so the equilibrium will shift to the left. Why left? If you look at this equation, endothermic refer to the reverse reaction, in which the equilibrium will shift to the left. Okay, so equilibrium shift to the left to regain equilibrium positions until Q equals to K. So as a result of this equilibrium shift, the concentrations of NH3 and O2 increase. And at the same time, concentrations of N2 and H2O decrease. To identify the values of K, how is it K respond? Then you have to refer to your Kc expression. The concentrations of NH2 and O2 increases. Concentrations of N2, H2O decrease. As a result, the values of your K constant decreases. Okay, so values of K decreases. Alright, so this is the answer that you may jot down for question number 1 for 1A, 1B, and 1C. Next, let's just look at question number 2. How does a decrease in temperature affect the partial pressure of the underlying substance and the value of Kp for each of the following reactions? So for 2A, you have carbon graphite. So remember over here, graphite refers to a solid carbon and reacting with hydrogen gas to produce methane gas. And given the delta H value is negative 1531 kilojoule. So the negative sign of your delta H indicate that the forward reaction is exothermic. Therefore, the reverse reaction is endothermic. Okay, so in our sentences, the forward reaction is exothermic. Therefore, when the temperature decreases, which is your disturbance, the exothermic reactions is favor. So this one refer to your step 2. Temperature decrease, exothermic reactions is favor. The equilibrium will shift to the right, which is your forward directions, to re-establish equilibrium positions until Q equals to K. So again, why is it moving towards the right-hand side? You need to refer to the forward reactions which you have written just now. Okay, so forward reactions, exothermic, temperature decrease, it favor exothermic. So follow the direction. As a result of the equilibrium shift to the right, the partial pressure of the hydrogen gas decreases, and the partial pressure of the methane gas increases. So it depends on the questions whether they are asking for the pressure or the concentration, so you answer accordingly. So looking at our Kp expressions, we have the partial pressure of methane gas on the top raised to the power of 1, and the partial pressure of the hydrogen gas raised to the power of 2. So carbon as a solid doesn't have any pressure. So after the equilibrium shift to the right, pressure of CH4 increases, pressure of H2 decreases, and resulting in the increasing of the Kp value. So value of Kp increases. And next, question 2b, given the equations N2 plus O2 in equilibrium with the product NO gas. So your delta H given the value 181 kilojoule. So if the delta H given doesn't have any sign, it is indicated as a positive value. Okay, so positive value indicate that the forward reaction is endothermic. So write the endothermic on top of your equilibrium arrow, so towards the right hand side. So the reverse reactions will be exothermic. So written in your explanations, the forward reactions is endothermic. So when the temperature decreases, exothermic reactions is favored. Therefore, the equilibrium will shift towards the left-hand side. Okay, follow your directions that you have indicated just now. So exothermic refer to a left direction. So equilibrium shift to the left to re-establish equilibrium positions until Q equals to K. So as a result of this equilibrium shift in the reverse direction, the partial pressure of N2 and partial pressure of O2 increase. And at the same time, partial pressure of the NO, nitrogen oxide gas, decreases. So to determine whether the values of K increases or decreases, again, look at your Kp expression. So decreasing in the partial pressure of NO, increasing partial pressure of N2 and O2 will result in a decreasing in the Kp value. So value of K decreases. One of the applications of Le Chatelier's principles is Haber process. So Haber process in an industrial productions of ammonia gas, which is an exothermic reaction. So exothermic is indicated by the negative values of the delta H. So nitrogen gas react with hydrogen gas to produce ammonia gas, and the forward reactions is exothermic, reverse reaction is endothermic. So to combining all the factors that we have learned previously, the factors of concentration, pressure, temperature, and so on. So we want to find one optimal condition and how it can be used to increase the productions of ammonia gas. Okay, so to increase the productions, in other words, we can say to increase the yield of ammonia. So looking at our first factors, we think about concentration. So there's two ways to increase the productions of ammonia. First of all, we can add nitrogen and hydrogen, or we can remove the product NH3. So by adding N2 and H2, you are actually increasing the concentrations of N2 and H2. By removing NH3, you are actually reducing or lower down the concentrations of NH3. Okay, so increasing concentrations of reactant, you will push the reaction to shift to the right hand side. Or to decrease the concentration of NH3, you are pushing the equilibrium to shift to the right. Secondly, the factors of pressure. Okay, so the pressure we will set, or the industrial process will set this pressure from 500 to 1000 atm. So we know that to increase the pressure of the system, equilibrium will shift to the side with fewer mole of gas molecule, which if you look at the equation, on the right-hand side, you have fewer mole. So you're pushing the equilibrium to shift to the right-hand side, therefore producing more ammonia. So over here, you can jot down to the right. Okay, next factors, you can look at temperature. We can increase the productions of ammonia by lowering the temperature. This is because the formations of ammonia, the forward reaction is exothermic. So exothermic reactions is a favor at low temperature. So if you're referring back to the equation, we want the reactions to proceed to the right-hand side. So you can producing more NH3. And towards the right-hand side is an exothermic reaction. So you need to refer to step 2 in the factors of temperature. If you want exothermic reaction, you need to lower down the temperature. However, lower down the temperature will reduce the reactions rate. Now, when you reduce the reaction rate in the industrial process, it will increase the cost, which is not preferable. Therefore, we will set an optimum or moderate temperature, which is in the range of 450 to 550 degrees Celsius. Okay, we need to lower down the temperature due to exothermic reaction, but we cannot take a very low temperature, so we just keep it moderate, 450 to 550. Lastly, the factors of catalyst. Remember that adding catalyst will not affect the equilibrium shift, but it can increase the rate of reaction. Therefore, iron Fe is used as the catalyst to increase the reactions rate. So overall, you have 4 suggestions to increase the production, but catalyst will only increase the rate of reaction. So usually I would suggest that if the question is asking to suggest one of the factors or one of the way, you can use concentration, you can use pressure, you can use temperature. But if you are using temperature, you need to combine with catalyst. Okay, so you use a lower temperature, but at the same time, you're using the catalyst to increase the rate. Okay, so that's it for your Haber process. Alright, so after the discussions about the Chatelier's principle, you need to do some exercises. So there is 4 questions for you to practice, and I want you to do question number 1 and question number 3, and we will discuss in our coming lesson. So question 1, question 3. Try to apply what we have learned in the previous lesson and for this video, and then to figure out the suggestions of answer. So I'll see you in the next lesson or the next video. That's it. Goodbye and thanks.